What's going on YouTube? Today we are going to dig deep into the Print Nightmare vulnerability, but from a defensive point of view or from the defensive security, which means we're going to go over a machine that on which the Print Nightmare vulnerability has been attempted from two perspectives or for two machines. So basically the first machine will be Print Nightmare again, and there is a dedicated room for that. And the other machine that we'll be discussing is Print Nightmare Thrice. Print Nightmare Thrice is actually the same as Print Nightmare again, but with a machine that's supposed to be more secure, that's supposed to be patched up with the recent vulnerability defenses that would protect against the Print Nightmare. So we have got two cases. What we're going to do, we're going to hop to the machine directly and start the investigation. Of course, the investigation, we will use the various tools, Windows Event Viewer, we're going to use Brim, we're going to use Process Monitor. All of these are tools available on the machines on which the Print Nightmare was attempted. So that's the first machine. On the first machine, we have got a log saved, as you can see, full event log view from the compromised machine or from the machine on which again the Print Nightmare has been attempted. I guess I'm gonna have to repeat this 100 times anyway. Okay, so and there are questions that would help you have a guided investigation. So the description says, in the weekly internal security meeting, it was reported that an employee overheard two co-workers discussing the Print Nightmare exploit and how they can use it to elevate their privileges on their local computers. Inspect the artifacts on the endpoint to detect the exploit they used. Okay, let's go and exploit. Let's go and detect the exploit, not exploit, of course. Alright, so what's the first question? The user downloaded a zip file. What was the zip file saved as? So probably this is the file, this is the first file that the user or the attacker downloaded to the machine in order to have the exploit unzipped and executed. So let's find that file. So this is the Windows event, or this is the full event log view that has been extracted. From here we're going to go to options, advanced options. I'm going to highlight show events from all times, and I'm going to show click on OK. As long as it's showing stop, we're gonna have to wait the full event log view to load all of the events, so there is a bit of waiting. Okay, so to find the zip file, as you can see, we have to sift through 33,000 here on the lower left, 33,239 items or events, which is going to be time consuming and near to impossible. So we're going to have to search. So we can pull up the search and type .zip, find next. Okay, here we go. So these are the events or the file creation events. It starts with this one. And it's very obvious that this file creation event indicates that the file was downloaded. And this is the image of the file. C Windows System32 Windows PowerShell v1.0 PowerShell.exe. That's the PowerShell file that has been done. Okay, not this one. This is DNS query. This is network connection. Oh, yeah, it was the first one. As you can see, that's the image. This is the file, or it means that PowerShell has been used to download the zip file. And that's the zip file. The zip file name is level up, and that's the full path. It was downloaded to the downloads directory of the user P Murphy. So that's the file. What's the full path to the exploit the user executed? So here we are before a file execution or a process execution event. Nevertheless, we can stay inside the chain of these events. So if we hop to file created again, this is an Excel file. We're looking for a file execution process. If you go to this one, so we have Microsoft Windows PowerShell, and the question is saying what's the full path to the exploit the user executed. So if we go back, as you can see, level up is a zip file. Now if we go back to file creation events, follow them up one by one. So here we have another file that has been executed with PowerShell, not this one. File creation, all of these are, yeah, we have this one. Look at this one. So they use PowerShell again to download this file and save it to this destination. C users B Murphy downloads CV 2021, and it is actually a PowerShell script. So that's obviously the main PowerShell script that has been downloaded by the attacker, and it's saved to this path. That's the answer. What was the temp location the malicious DLL was saved to? So upon executing the process or the exploit process, there was a DLL that was saved to a temporary directory. So you have to look for a DLL file. That's the DLL file, as you can see, downloaded by PowerShell. Let's see where it was saved to. We're looking for a temporary directory here. Let's go back. I think I missed the events. Let's go back and filter again for level up. It's annoying, I know. So that is a DLL, as you can see. But we are looking for a temporary directory to which the DLL was saved. So here was the answer was this one, but we have to find it somehow. If we look for temp, okay, so as you can see we have a file creation event here, and it indicates that the DLL we saw earlier downloaded by PowerShell and saved to this temporary directory. So that marks the answer for this question. So what was the full location the DLL loads from? So the DLL loads from specific place or specific directory in the Windows operating system. So you have to find that directory. So we have to look again at the file creation events. So the DLL in question is Nightmare. As you can see, the printer or the print spooler service loaded the DLL, the malicious DLL, from this path. And that's where the exploitation started. The exploitation works by importing functions and DLLs, right, from the Windows operating system. So it actually imported, or it saved that DLL to the temporary directory, and then it imported it from this location. What's the primary registry path associated with this attack? Again, there was a registry key that has been modified by this exploit, so we're gonna have to find this. And we have here a file, we have a registry event, and this indicates the registry key that has been modified. But what? By what? By the print spooler executable. So as you can see, the exploit started, it worked, it executed, it was executed, and then all of the work was carried over to the print spooler executable to do the work. What was the PID for the process that would have been blocked from loading an Microsoft signed binary? Okay. The event right after that one, the description says process device hard disk volume 2 under this print spooler again with the PID 2600 would have been blocked from loading the non-Microsoft signed binary. So this means, guys, that by virtue of the exploit here, the print spooler executable loaded a non-Microsoft signed binary, which was the malicious DLL. That's how it worked. The malicious DLL was downloaded, imported to this path, and then was used by the print spooler service. So it can be said that again, this exploit wasn't only an exploit of the Print Nightmare vulnerability, but it was also a DLL hijacking, where a malicious DLL was used instead of an original Microsoft signed DLL. What is the username of the newly created local administrator account? If we follow up with the event after that, we have a member was added to the security enabled group. We're looking for user creation events, and they can be filtered, by the way, using the corresponding ID 4720, and indicates that there was a user called backup has been added to the system. That was the user in question. What's the password for this user, and what two commands did the user execute to cover their tracks? These two questions cannot be answered without looking into the command line history of PowerShell. So you have to go to the command line history of PowerShell. So we have to load up PowerShell first. And we're gonna maximize the fonts for you. I'm going to cd back, cd, yeah. Again, go to pmurphy, cd up data, cd roaming. Let's see what we have here. cd Microsoft. I guess we're going to go to Windows, and here we're going to select PowerShell, cd ps redline, and here we find the console history, which displays all of the commands that were executed. So we type console history and we find all of the commands. So it starts with here, wget. So it retrieved the, as you can see guys, you can find the answers for some of the questions by reading the PowerShell history. So as you can see, this command pulled up the level up zip file from this repository, right? And then, as you can see here, it extracted the files from the zipped file, and then, as you can see, this is the directory of the vulnerability, and we have the the exploit, and we have the PowerShell exploit name, right? And there you go, guys. This is the new user that has been created with the new password. And right after that, it was added, the user backup was added to the administrators group, and then the attacker, what they did, they removed the directory they created after extracting the zip file, and then they deleted the zip file as well to cover their tracks. So that's the chain of events. The user, to exploit the Print Nightmare, first they retrieved the zip file from this repository, and then they extracted all of the files from the level up, which includes actually the PowerShell script. Now they executed the PowerShell script, as you can see from this command, and after the PowerShell execution, the events happened starting from here. The malicious DLL was loaded, right, and executed by the print spooler service. The register key was modified, and then a user was added to the administrators group to maintain the access, and then the tracks have been cleared or covered. So that's the first scenario. A user got access to a machine, they downloaded the exploit, executed the PowerShell script, added the user for the maintenance, got root access, and that's it. Now let's go over to the other scenario. So I'm going to terminate this machine, close here and close here. And now we have the other scenario, Print Nightmare thrice. These are two separate rooms, but I combined them both to maximize on the learning benefit for you guys. So as you can see here, this is the other machine. Here we have more than one tool to use to complete the investigation. So on this machine, we have more security measures that have been implemented to prevent the Print Nightmare from being exploited, but unfortunately the attackers found another way to sneak in and exploit the Print Nightmare one more time. So to do that, we have got several tools. As you can see, we have got the full event log view again. I'm going to pull that up. Now all of these artifacts you can extract from the machine by doing full memory dump and full disk dump, or you can also only extract the logs from the Windows event logs and work on them using the event viewer. In addition to Wireshark, so Wireshark here will be used to investigate the PCAP file. The PCAP file can be a file that is pulled from a firewall that has the capability of network sniffing, or it can be pulled from an IDS such as Snort at the time of the event. So let's make this bigger as well. And we have again, as a supplementary network analysis tool, we have a Brim. You can also start Brim to analyze again the traffic or the PCAP file. Things may take some time as we are starting more than one program. So Wireshark here, still starting. We're going to open and select the traffic PCAP file. It will load the packets. Okay. So, event viewer, Wireshark, and there you go. We have got Brim, which is a network analysis tool. We have covered Brim in many scenarios, but I promise you guys I'm going to dedicate a separate video for the Brim so that you add another tool for network analysis to your arsenal in addition to Wireshark. So this is the PCAP. We're going to double click on that, and yeah, so we have it. And lastly, we have a log file of the processes that were running at the time of detecting the incident. We're going to double click here and execute the log file. It will open in process monitor. Okay, leave this running. Let's go now and investigate. Now, again, the questions here were laid down or were written to guide your investigation. The first question is, what is the remote address did the employee navigate to? So that's the first step. The attacker, or let me say the insider, took to actually download the Print Nightmare exploit. They navigated to a remote address. Now, initially, we would think of this address as an address on the web. Typically a web server with a page from which to download the exploit, like GitHub, right? But now if we go to the, if we pull up Wireshark, okay, we take a look at the packets first. Let's make an initial assessment of the kind of packets that were captured at the time of the incident detection, so we can make an informed or educated decision which protocol to investigate. So we have got all of the TCP, as you can see. What we can do, we can go to statistics and pull up the conversations. So TCP, so we have port 43. Let's see here. So port 80, as you can see, on the destination, 445. UDP, we have got port 53. 53, 55. Okay, which means we have more than one protocol to investigate. So we have port HTTP packets over 443 HTTPS, and we have 445, which means we have SMB protocol here for file sharing. All right, so let's close that and go back. So if we type only hey HTTP, okay, now you will not find the answer for the first question in these packets, but I'm just showing you guys the methodology. So as you can see, we have here communications over the HTTP protocol. Obviously there are some activity here, but it doesn't, let's take a look at the domain here that was contacted. As you can see, it is windows.com. Here we have Microsoft. So most of these domains are P9 domains that have been contacted. So this concludes that there was nothing malicious that was taking place over the protocol hey HTTP. So we're going to close this one and go back to the statistics here, pull up the conversations, Let's sort the packets and take a look at which port. 3389 remote desktop, port 8445. If we pull up the RDB here, okay, let's pull up SMB then. The next one is SMB. Alright, and we have this. Negotiate protocol requests from this IP to this IP address. So there was a connection request initiated from this IP address to this IP address, right? Using protocol SMB here. Let's take a look at the conversation. Okay. SMB header. So it was only a connection request. Alright, if we go back, as you can see, we have many instances of SMB2 this time. If we type SMB2, right, so here you go. We have how many packets? We have so many packets in here over the protocol SMB, which means probably the person who initiated these connections was trying to download something from a file share or to connect to some sort of file share. And this is very clear from here. We have users R. Jones, we have login failure. Let's investigate. As you can see, negotiate protocol response. After that, negotiate protocol request from this IP to this IP. Followed by, as you can see here, the response. And here, as you can see, we have log on failure. And that's the user. So it's safe to conclude, guys, that the employee or the IP address that the employee was trying to connect to was this IP address over the protocol SMB2. Period the PCAP, which user returns a status log on failure error. Okay, that's the answer is here. So if you follow the packets here, status more processing required. After that, as you can see, there was an authentication attempt with the user R. Jones. That's the username, right? And it was received with, it was welcomed, sorry, with status log on failure, right? So that's the username. Which user successfully connects to an SMB share. Okay, so if we follow through the chains here of packets, we can see a pattern of login failures by the user R. Jones. As you can see, all of these are logon failures. If we follow these, eventually, if they got access and if they downloaded the exploit, it means they would have actually, or they actually have successfully logged onto the SMB server to retrieve the exploit, right? So let's look for a success attempt or a success event, and there you go. As you can see, this user this time, gentle guest, was used, right, to connect to the SMB server at this IP address. And it was received with not status logon failure, it was received with session setup response, which means the session was actually pulled up and started. And there you go. As you can see, this is the path of the share that they connected to. So there you go, the username that was actually or that resulted in a successful login. And as you can see, this is the share that they first discovered. That's the user. And that's the first, as you can see, remote SMB share. What's the first? Remote SMB share. The endpoint connected to, we already found this one. What was the first file name and what was the second file name? Let's see here. So this is the first share, right? Now, as you can see, take a look at this one. Request file. A file was requested from this share, as you can see, by the local IP address of the machine. The file name is service svc. It was requested more than one time. So that's the first file. If you scroll down, we see another file request, spool SS. That was the second file that was requested again by, as you can see, the local machine, the source IP address. These are the two files here. Okay. From which remote SMB share? We got another remote SMB share here from which remote SMB share was malicious DLL obtained. So we are on the same server, right? But there was another share to which the user navigated to, right? And from which a malicious DLL was retrieved. Obviously, this is the DLL that will be used by the employee to exploit the print nightmare. So what was this DLL? And what was the path to the remote folder? For the first DLL, how about the second one? Let's look for another share here. Scrolling all the way down, we're looking for another share. The first share was IPC. Now the other share is supposed to be somewhere here around these packets. Gonna keep scrolling. And yes, that's the other share, as you can see here. So, Print Nightmare, Gentle Wiki, Print. So that's the other share. Okay, what happened here? As you can see, several files were attempted to be retrieved. Create file request x64. And if we followed, as you can see, we have many file requests and many DLLs. Now, obviously, guys, finding the right DLL through Wireshark can be a bit difficult because we have so many file requests and we don't know which one is the right one. So we're gonna have to turn our heads to Brim. And here we're going to select file activity. By selecting file activity on the left with the queries, it pulls up the DLLs, as you can see here, that were downloaded, right? Downloaded by whom? By the local IP address. And this is the path for both the DLLs. So this is the share name, and these are the path to the both of the DLLs. So that was the malicious DLL retrieved from the remote SMB share. Okay. What was the first location? So we found the names of the DLLs. Now, what was the first location the malicious DLL was downloaded to on the endpoint? And what was the second one? Now here, as you know, guys, the employee retrieved to understand how this happened. The employee logged in to the SMB share at this address, SMB server, with this username, and they located two SMB shares. The first one with IPC, and the other one ends with print. Now the malicious DLL they created to exploit the print nightmare was actually stored on this share. So we have two, and they were downloaded to a location on the endpoint. So you have to find that location. Of course, when we want to find the local locations, we're going to turn our heads to Event Viewer. And obviously, we're going to search with the DLL name. So options, again, advanced options. And there you go. We're going to show all event IDs and show all time. So we're gonna wait for this to finish. Yes, you have to be patient till this finishes. Okay. Not finished yet, but we are close to finishing. Well, it seems like we're gonna have to wait a lot, right? Okay. Let's leave this one till the end because I know you guys, you don't like waiting. Me too. What's the folder? Let's suppose that we found the path to which the endpoint was downloaded to. Now, what's the folder that has the name of the remote printer server the user connected to? Okay, so there is a folder on the local machine that bears the name of the SMB share. the user connected to. That's the name of the SMB share the user connected to find the name of the folder that went by the name of the SMB share the user connected to. We're going to navigate to the local path here. So let's go back. Obviously, this is the infected machine. Pulling up Explorer now. Things taking a bit longer than usual. Yeah, so it's still loading events. Wow. And the Explorer is not loading, so I don't know how much we can wait. Okay, this one finished. Let's take now the DLL name and look up the name here in. Okay, so search, find next. All right, so that's the first occurrence. So as you can see here, a file creation event by the print spooler service, and as you can see, this is the first path to which it was downloaded to. That's the first path. The other path is we're gonna have to go along with the events, and that's the other one. So these two paths were the paths to which the malicious DLLs were downloaded to. What's the folder that has the name of the remote printer share? Now we have to go to, oops, this is my Windows. We have to go to the File Explorer, which didn't start yet. Try one more time. PC, going to now local disk, navigate to Windows. System 32. Okay, scrolling down. Spool, printers or servers, and this is the folder name. As you can see, it has the name of the same SMB share server that is connected to. It's empty now. Okay, what's the name of the printer the DLL added? So obviously when the DLL was pulled from the SMB share, let me call it the malicious DLL, when it was pulled from the SMB share and stored at this location, it actually created a new printer. So to find a new printer name obviously can be found with the event viewer. So from the time of the downloading the DLL, as you can see, there was another event followed after that, which indicates that the DLL was associated with a printer called Kiwi Legit Printer. Okay, for the last two questions, we're gonna have to use the process monitor. So we're gonna close this one to lighten the weight on the machine and make it faster. Okay, now open up, pulling up the process monitor. So what was the process ID for the elevated command prompt? What was its parent process? Here we have to find information about the processes. What was the process ID for the elevated command prompt? So it was the command prompt used here. So we're going to go to filter, and here say image path, process name is CMD, add and apply. Let's take a look at the processes where the process name is CMD. Okay, so it finished. Okay, so processes start, It was CMD. Now the question is saying, what is the process ID? As you can, the process ID is 5408. Okay. What was its parent process? We're going to look at the parent process of this process. So right click, properties. That's the parent PID, 2640. Right? Now to find the process of this parent PID, we're going to have to look with this parent PID or filter with it. That's the question. What's its parent process? So going back again, properties 2640. So again, the filter, disable this one and put PID is 2640, add, apply, and there you go. Let's see. So we're looking for a process here. As you can see, the process 2640 has done all of these operations. Properties, process. If you look at the process, it's the print to spooler service, and that's the usual executable that happens to be the victim of the print nightmare all the time. So always investigate this process. What command did the user perform to elevate their privileges? Okay, what command did the user perform to elevate their privileges? Obviously, we're gonna have to go back to the wait for me, to the event log viewer here one more time. But this time, we're gonna need the clue by which or through which we're going to search in the event log. So the clue is actually the parent process PID here. We can search either with the 5408, which happens to be the PID of the command prompt process, or with the PID, which is 2640. So close this one, and unfortunately we're gonna have to open this one and linger one more time till this finishes. I know, guys, I shouldn't have closed this, but yeah. This is the command. If you want to finish the video, guys, you can close up the video because that's the last answer here. So we're going to search either with this PID or with the PID of the parent process, which happens to be the print spooler 2640. But obviously we're gonna have to wait this to finish. Let's close that and close Wireshark since we finished. I don't think we're gonna get back to these. This is the last question. And it's still loading. Approximately 20,000 events. Probably we're gonna need to wait till it goes up to maybe 70,000 events. And as you can see, guys, this is the room that shows the other side of the print nightmare. So if you want to practice exploiting the print nightmare yourself from an offensive perspective, or maybe if the word was correct, the red team perspective, you can do this room. Here you learn how to use the exploit CVE 2021 and CVE 2021 etc. guys. I'm gonna spell the numbers. So to practice and just see how it goes while exploiting the print nightmare. Now this is from the offensive security perspective. What we have done so far in the print nightmare thrice and print nightmare again is investigating what are the artifacts that can be collected on a machine that might be the victim of a print nightmare attack or a print nightmare exploit. Alright, so let's look for 2640, which happens to be the PID or the parent PID process of the print spooler. Let's see here. So we have this one. Okay, next. Obviously, this is not the correct way of looking for the answer. So let's look up here Windows event logs parent process ID. We want to find the field name for the parent process ID, or yeah, field. Windows event parent process ID field. Yeah, let's take a look at this one. No, this is logarithm, not the one we want. This is process ID. So if you append parent here, parent process ID, and as you can see, we have entries with this field, parent process ID. Let's filter for 2640. And this is the print spooler service, right? As you can see, it's using the command line. Okay, next. Next. Yeah, it got stuck. Okay, next, one more time. You have to be really patient with this one. Okay, up. Okay, let me take this and start from the beginning. Because obviously this, if we keep doing this, we're gonna end up in an indefinite loop. Okay, that's the first one. So no comments here. Next one. It's not working here. So let's look with 5408. So 5408. And this time we got some commands here under the command line field. Net user Jones. So what the command did is it performed to elevate privileges. Yeah, this one. Net local group administrators R Jones add. To add, they recently added user to the administrator group. So that reveals the answer or the elevation of privilege attempt. So guys, that was today's video. 2 rooms in one. Full investigation on the Print Nightmare vulnerability or exploit from the defensive security perspective. I hope you like that, and I will see you in the next video.